Homework 3.2, Polynomial Functions, Video 8. Homework due Wednesday, May 27th, 2020 at 11:59 p.m. This video is associated with questions 10 through 14. Example 3. One function we analyzed previously was h of x equals negative x to the fifth plus x to the third. And since we analyzed it previously, I'm just going to write the results of the end behavior and the x-intercepts. The end behavior on this one was that the left rises and the right falls. The maximum number of turns is 5 minus 1, which equals 4. So it can turn 4 times, or it can turn 2 times, or it can turn no times. I think it's pretty obvious this is an odd function because all the powers are odd. And that means that it's going to have origin symmetry, which means that if we get one side of the graph, we can rotate it 180 degrees to get the other side. The y-intercept is pretty easy. If we plug in 0, we'll get out 0 on this one. The x-intercepts on this were x equals 3, and I know I crossed out multiplicities, but I'm sorry, x equals 0. And I know I crossed out the word multiplicity, but I want to remind you that the multiplicity of this x-intercept was 2, and the multiplicity of the other x-intercepts, I'm sorry, it was 3. What am I doing? The x-intercept is 0, and its multiplicity was 3. Yes, go back and check it. The other x-intercepts were 1 and negative 1, but their multiplicities were both 1. Yeah. Sorry, folks, I wasn't planning on writing multiplicities, but there's a subtle point I want to make. Each of these multiplicities were 1, and it crossed in all of these. Cross, cross, and cross. So what does this one look like, and why am I talking about the multiplicities in this one but not the other ones? Well, let's start by sketching the graph, and at the end I'll tell you the impact the multiplicities have in addition to predicting crossing versus turning. Our end behavior. Left is going to rise, right is going to fall. Sorry, that arrow is just bothering me. Right's going to fall. It can turn up to 4 times, but it doesn't have to turn 4 times. The y-intercept is at 0. That's also an x-intercept. Speaking of x-intercepts, we've got one back here at negative 1 and one at positive 1. At 1 and negative 1, we're going to cross as we are here. But here's the impact that multiplicity has in addition to predicting crossing versus touching and turning. The larger the multiplicity, the flatter the graph. The larger the multiplicity, the flatter the graph. And I'm going to illustrate this here in just a second. All right, let's draw the graph. We're going to start high, cross, 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 and go low. Now, you might just be thinking go down, up, and down. But if you really want to capture everything multiplicity tells you, the larger the multiplicity, the flatter the graph at that x-intercept. Because this multiplicity is 3, I'm going to expect the graph to flatten out some before it crosses. When the multiplicity is 1, just shoot straight through. So start high, shoot straight through here. We're going to turn around, but because this multiplicity was higher, the graph's actually going to flatten out a little bit. And then we're going to do the same thing, continue, and then cross. Let's take advantage of the fact that this has origin symmetry, spin this thing 180 degrees, and it would look something like this. Now, how many times does this graph turn? In other words, how many times does it switch between decreasing and increasing? This graph is decreasing and then it's increasing. Doesn't really turn here, it just wiggles, but it turns there. So this only had 2 turns, but the maximum was 4. If we change some things, we could get it to turn 4 times, but this one only turned twice. So again, to reiterate, that wasn't redundant. The higher the multiplicity, the flatter the graph is at the x-axis. So if you had a multiplicity of 5 or 6 or 7, your graph almost becomes horizontal. Very briefly, it never actually does, but it looks like it.